First of all, I'd like to welcome you guys to Quid. And like I said, I'm Saro, VP of Engineering here. And I have my colleagues here also. We'll be talking about what Quid is and some of the challenges that we have solved and some of the interesting challenges they were working on. So it gives you a good idea about where we are and what we do. Yeah. OK. Can you guys hear me now? Great. Cool. So how many of you guys know what Quid does? I see one. I see a few Quidizens not even raising their hands, so I'm kind of worried about that. But OK, so this is important. Like, I'll not take too much time because the fun part of the stuff is going to be later on with the demos and under the hood. But I'll go over a little bit over what Quid does, and then we'll show you a demo and there are a few interesting challenges that we thought would be interesting to share with you guys. And Derek and Grant are going to be talking about that. Yes, we are always hiring. So there are certain kind of questions that you can answer easily with a Google search. What's the nearest sushi place around here? Or what was the score for the last, cricket match between India and Pakistan, given my background. And it's, Google answers those kinds of questions pretty nicely, and that's where everyone uses. But then there are certain kind of questions that, strategic questions, which are much harder to answer, and honestly, it takes a lot of time and research to do that. Like, if you look at what makes a customer happy, or what market to enter, how are you doing against your competition on a certain on brands and topics, and how's your what are the areas that your competition is researching on? It's really hard questions to answer, and there are a lot of signals out there that will help you answer these questions. Every day there are 1 million to 2 million news articles and blog items that are written about various topics, right? And there are more than 1 million scientific papers that are published every year. There are more than 15 million patents that are out there to be researched on. But it's really hard to kind of see what's been said about a certain topic across, because the volume of the data is so large. And Quid, there are tools like Google I talked about. You do a search, you get 40 million results, and you don't know how they're all related, what they're really saying. Most of the time, for most of us at least, if the answer is not in the first 1, 2, 3 links, then you go and change the search query, right? And there are other companies that do a little bit of sentiment analysis on Twitter streams and things like that, but it doesn't really answer questions that are around narratives. And if you really have to understand what a 10-page New York article is talking about, it's really hard to kind of understand that. And if you have 10,000 such articles talking about a certain topic, how do you really analyze what's been said and really consume okay, so this is where the trend is, or this is that landscape of the conversation that's happening there. And just as an example, if you kind of look at this, if you go and search Tesla in Google, you get a great set of results. You can see that you get the home page. You have some articles about the recent news about Tesla. You can see that a reference to their Twitter handle, where the showrooms are, and the stock price, and some information about founders directly coming from Wikipedia, right? And that answers certain kinds of questions. In Quid, what you really get to see is all the different topics that are associated with Tesla. for this example. From here, you could see that, one of the central topic of discussion here is, Silicon Valley disruption and what that really means, or climate change. And those are two things that you would not necessarily think about, even though once you kind of look at it, it becomes very obvious. Yes, I mean, these are the topics that Tesla is really associated with when people are discussing about these topics, but it's not very relevant with just saying there are 143 million records about Tesla, right? And you can also see that there is conversation about autonomous driving and how things are, and Tesla is actually one of the serious players in there. You can see there are topics around, Model S recalls, and that's been really covered. So for a brand like Tesla, it might be very interesting how their brand is associated with various different conversations, right? So what is Quid? So Quid is a platform that allows you to really comprehend any topic. It searches, analyzes, and really visualize, any topic of interest. We get data from, disparate data sources, and we have our own, models and algorithms that run on it, and we have a very strong visualization on top of it that allows you to explore any topic of interest. So, okay. I was just a little slow in updating. So, we ingest, about 1 to 2 million articles a day. We have data on patents. We have data about company financials and new startups and investments and all of that. And blogs, we also have ability to, get into custom data that might be that might be an internal proprietary data that an organization has that they want to really analyze. And we run various models on it, models that can really understand the language semantics and the narrative in there, and really figure out, extract keywords, entities, events, and really see the relationship between them and bubble up the different contexts within those topics. So, and we have, and this might be for this group the most interesting part, and then we have a very visually engaging way to kind of interact with that data and present it for a user to immediately understand what are the most significant things that are being discussed on a given topic. So putting all those three together, you could kind of answer all these different questions, and it is applicable across various verticals. Be it marketing or be it a PR organization or someone doing research on what's the next best thing that they need to be looking at. And these are some of the type of questions that you can easily answer with Quid. We have over 100 customers, and this is just a sample of some of the people who are currently using Quid. We've been around for about 4.5 years, and we have about 100 people in the company and 25 plus engineering team. We're going to be going through a little bit of a demo after this, and also be talking about some of the interesting problems that we have solved in the past, which will give you a good idea about some of the interesting challenges that we are working on too. So I think with that, we'll go into the demo.
So thanks, Saro. So my name is Derek Gathright. I'm a software engineer here at Quid. I've been around for about 2 years, and my task today is to give you guys a demonstration. And along the way, I'm going to point out some of the things about how we built it and why we made some certain decisions along the way. So first, to familiarize you with the interface, by the way, this is a network that I generated searching data science earlier today. So this is a news network. Each of these little dots represents some news article that we've pulled into our system that is somehow associated to data science. So over here in the what we call the view panel, there's all sorts of different things you can do with nodes, labels, links, display, hide those. And then specifically with nodes, you can change the color representation, as well as go through and change what the size is, and something that we call, at least internally, we call pivoting, which is if you, as I mentioned before, each of those dots represents a news story. So we have here something about constant contact. So if we change each of those nodes to represent clusters, so we're going to take all of those nodes that are embedded inside of those clusters and turn them into one singular node. And so if we click on here, we'll see startups and 159 stories represented within that cluster. As I'll show you later, you can do some interesting things when you get into this pivoted mode, which is looking at data from another dimension. There's some other things you could do here. As I mentioned, this was data science. So who are the major people involved in data science? So here we see the layout taking place. Who are some of the major ones? Mark Bainoff, I think what, Salesforce? Dr. Alec Choudhary, I'm not sure what, looks like Fuse TV. So something about connected TV and social media. But so yeah, this is just a network of probably about 1,000 different people involved in data science. And so looking around the rest of the interface, I change that back to stories. Like you can go through and tag nodes, you can apply filters. Up here at the top, list out like various saved views. You can save the configuration state. And what we call packaged views, you can go through and we have default configurations that allow you to explore some, what we have kind of found is interesting configurations of these networks. Then, yeah, you also have the color legend. Let's go back to original view. Yeah, so you also have the color legend and over here, these selection summary panel. So let's see. The first thing I wanted to talk to you guys about is the physics engine that we have going on. I don't know if you guys know this, but fortunately, physics is one of those things that nature has actually already solved for us. So as engineers, if we want to build a physics simulation engine, we just have to go through and apply all of these formulas that scientists 400 or 500 years ago discovered. And one of the great things of working at Quid is we have physicists here on the data science team that help us as engineers kind of understand how that works and how we can apply them. So in the guts of this model, we're using Hooke's law to simulate attraction, Coulomb's law for repulsion, and we're offloading all of that calculation into web workers to keep the interface pretty snappy. So if I do like optimize layout and zoom in, like there's not any lag or very, very not noticeable lag going on. And most importantly, oh, I did want to mention like D3, we're using Barnes Hut trees for approximation. And importantly, this is a deterministic layout. So every time we run the layout, you're going to get the exact same thing. And this is done by beginning with a fractal layout. And as long as you eliminate any randomness that's introduced into the system, you're going to get the same result every time. If this is something that's kind of interesting that you want to apply in any physics simulations that you have, there's a blog post on our technology blog, technology.quid.com. So let's look over and jump to something else that's on here. To do this, we move over into scatter plots and change the nodes to represent clusters. So here's all the clusters that we've found in data science. So education, talent, startups, social, politics, enterprise. Let's apply some of these filters that I have on here. And go back here, toggle these, toggle that. Okay, so one of the things that we added into, that we've added into Quid that we think is actually really beneficial for users is, so if you look down here at the bottom, I'll highlight these four, no, those five. It looks like they're all pretty much hovering down at, on, this is social sharing. So this is just a metric measuring the number of, or the conversation that's going on in social media. So all of these, they're pretty much right at 0. So nobody's discussing retail and advertising and events in data science. That's not actually accurate. If you change the y-axis to a log scale, you'll see that there is conversation taking place, like not really much around events. Sorry, meetup. But around like retail, and so enterprise was one that was really low before. But when you look at it from a log scale perspective, you actually do, it does make a little bit more sense. So, and with log scales, like fractional changes become equivalent. So that just helps eliminate any misinterpretation of some consistent momentum that's going on. Giving users the power to view log scales is important because if you didn't know, humans innately think in log scale. From an early age, we're taught how our linear scale system works, but without that education, like, as I mentioned, humans innately think in logarithmic terms. So there's some really interesting scientific studies that dive into this. And in particular, if anybody's like a Radiolab podcast fan, there's a really great, episode called Numbers, where they dive into this as well. So it really helps reduce the complexity of scale, not only just to visualize, but also to understand. So let's switch over to another view that we have. This is a save view I created earlier. Cities. So this is actually all the cities that are involved in, the top 10 cities in the world involved in data science. So naturally, San Francisco is number 1, and then there's also New York City, and then you can see the relationships between those cities as well. So I'll let that run while I go ahead and talk about another thing, which is our application architecture. So 2 years ago, we were off in library land. That was the place of Three.js, jQuery, Backbone, Rails, underscore, Moment, like you name it, we probably had it in our application. Obviously, that presented some issues, performance, maintenance, upgrading. But since then, we've gone to the complete other end of the not invented here spectrum. And I'm happy to say that Quid now is entirely built by our own engineering team. We needed something very specific, something very performant, and actually very special too. So what we're working on now doesn't actually have jQuery or Backbone, React, or Ember, or D3. We own it from top to bottom. And just from a personal note, like I spent years at Yahoo building open source JavaScript libraries and frameworks, and some of that is out being used by billions of a billion end users. So I understand that like building libraries can be tough, and they do a lot of heavy lifting for us. But building libraries for your own internal use can also be incredibly simple and fun though too. So if you look at some of the things that you get out of web frameworks and libraries, what do you get? Cross-browser compatibility. But at Quid, we're building an application that's exclusively for bleeding edge web browsers. So, and we prioritize web standards. So that just means Firefox, Chrome, and some of the other ones out there. So, and that allows, once web standards hit those browsers, we can begin experimenting with them right away and introduce them in new releases relatively quickly. Another thing that libraries will give you is novel approaches to common problems. Eventually, though, some of that novelty wears off. jQuery at one point was really novel. Backbone at one point was really novel. React at one point was really novel, but eventually it becomes a solved problem, and the good bits that are out of there can easily be referenced. Another thing you get is wide feature sets. Well, a lot of times with libraries, we only use about 10% of the overall features and functionality of libraries. And so while at Quid we acknowledge that like not invented here can certainly have some downsides, but we've also experienced that it can have some great upsides too. So things like a much smaller code base, easy debugging, more maintainable, swappable, upgradable, and iterative development. There's also a quick ramp up for new hires, and most importantly, we just have a lot of fun experimenting with it. So that's the conclusion of my portion. I'm going to go ahead and turn it over to Grant Titus, another engineer here at Quid, who's going to tell us about a very specific problem that we've solved.
All right, hey guys. So Derek gave you, a general overview of some of the technical challenges that we faced. Those being running physics simulation for force structured graphs, log-to-log scales, ditching a lot of open source libraries and frameworks, and building stuff on our own. One of the things I'm going to talk about is some of the rendering challenges that came with that. So ditching 3JS, which is what we used, and building all of our stuff with WebGL by ourselves afforded a lot of challenges. So the main one being curved edges. So as you can see here, the edges between nodes isn't just a straight edge, but it's curved. We do this because we think it looks better. So there's a few cool things about that, just to talk about from Canvas API to WebGL. So benefits of Canvas API for drawing arcs or edges, it's super easy to do. Look at that, you begin path, arc 2, give it a to and from position, then stroke, and then you're done. Like, that's awesome, super easy. Downside is it's really slow. So if you try and do 50,000 edges this way, updated every frame, you're gonna have lag. Along with edges, or along with vertices and other stuff, it becomes really difficult. So we needed something that was much faster, and that turned out to be WebGL. The only downside with WebGL is it's a lot more involved. So as you can see in this picture, there's a lot of things that you have to worry about. Defining your own vertex shaders, fragment shaders. You have to pass in data such as like the vertex data, camera position, colors, what other data you want in buffers to the GPU. We don't do anything with bitmaps and video, but there's a lot more that you have to consider here, and I'm not really going to talk about vertex shaders or fragment shaders or any of those things. Just going to give a high-level overview of what we've done. So let's just go through and see what does it take to make an edge between two vertices. So two vertices right here, we want to draw an edge between them. So first thing that we do, we want to define a function that describes our curve. So as you can see here, this is what we want it to look like. It's modeled after this function here. So you can change this. This is not actually the one we use, but it's very similar. Whoa. Don't look. Okay. Okay, cool. So we have this. Now we have to define the area in which we draw. So WebGL is not like Canvas where you can just draw all over the place. You have to define triangles or points, and then that will run through vertex and fragment shaders. So the very first implementation that we did, let's say we have two vertices and we build this triangle. So you can see in the background there's this light triangle. And this will define the area, which then we can take like a paintbrush and draw the line, the curve that we want to do. So this is cool, but there's a few problems with it. If you look near the edges, you'll see a lot of clipping, because as the triangle approaches the vertices, it becomes a single point. So you lose a lot of that width that you had at the center, which makes things look really bad if your application can scale the link size and the node size, which ours does. So this was right when we were prototyping WebGL. It's really cool, initial prototype, but it wasn't going to work long term. And another issue for this is when you have vertices that are really far apart, then your triangle becomes gigantic, which is a lot of wasted time that you're sitting in the fragment shader, going over all these fragments that they're never going to be visible. So you want to be able to avoid that if you want to have a fast application. So how do we define the area which we're going to draw? Minimal area, do it fast, make it look good. One thing that one of our data science guys here thought of, David Smith, he's a PhD in mathematics. He solved this problem, and he decided, or he knew, he's like, I'll make a sleeve. Basically, a sleeve is like a wrapper around this function right here, but that's comprised of triangles, because that's all we have to draw with. So we made this really cool script that will take 2 points and the number of triangles that you want, and define the points that comprise this sleeve, as you can call it. There's trade-offs. You see the very top one, there's tons of triangles. It looks really nice, gives you really smooth edge. But when you have an application, if you're buffering, like 24 edges or 24 triangles to the GPU each frame for 50,000 vertices, that's not going to work really well. So you can go down, pick a more primitive, more basic implementation of the sleeve and use that. At boost performance, but it might not look as good. So what we ended up doing, taking this middle guy and using this to define the area. So we have this script which outputs these points that represent all these triangles. So on a plane from like -1 to 1, x on the x dimension. Once you have these, you can pass this standard curve, or these standard triangles, to the vertex shader, and then the vertex shader can do linear transformations based on the 2 endpoints, so based on the 2 vertices. So you do this for every guy, which will orient it however the nodes may be. And that will give us this really cool area which we can then draw in. So we go here, go to the fragment shader. Now you add some color. You can still see in the background, this is the sleeve that we have. Made it visible just so you can see how it goes. But then you have the edge where we still have a lot of room where we can increase the thickness or decrease the thickness, which is really nice. We don't have any of the problems that we used to have. The area is much smaller. So the only downside is you have to buffer more data to the GPU. But it's, from what we've seen, like we haven't done much benchmarking on it, but it seemed to work out in our favor doing it that way. So, and then in the end, you'll get something similar to that. It's not an actual screenshot, just made that up, but that would be the final goal, which would look cool. So that's basically it for me.
Hope you guys had enjoyed the demo, got to know a little bit about Quid. Like I said, we are close to about 100 people at Quid, and the engineering team's around 25 people. But we are hiring, and we are actually hiring across the board. Our website has maybe another 7, 8 more openings. We are hiring, obviously, in the visualization team. These 2 guys are part of. But we are also hiring in the back-end platform, QA and automation. We're also hiring data scientists. So if you guys are, if anyone of you interested, or anyone in your network you think would be interested, please feel free to connect with us, and we can have a conversation. I think that's about it for us. If you have any questions, we are happy to answer.